Good morning, students. So, day 16 today. Okay, so you are getting my voice clearly? Any problem is there in that? Right. Okay. So, let's finish today waves. Okay. So, what is remaining? Small portion is remaining now. So, we were discussing yesterday about standing wave, and standing wave is what we said when two similar waves are coming from two opposite sides and they are interfering or superposition of them is happening, then we get standing wave. So, what type of waves? What we can say? Suppose one wave is A sine omega t minus kx, and other one A sine omega t plus kx. Okay, we are going to have superposition of them, interference. What will happen? We have to add them, right? When we add them, we will get some equation like this with 2a sine kx cos omega t. Okay, this is called standing wave. Okay, this is called standing wave. Now, this can be given in cos function, or this can be given in another way like omega t plus kx is this one, and this is minus a sine omega t. Okay, that way we can have multiple functions like this. Like this is 2a sine kx cos omega t, we could have get 2a sine kx sine omega t also, or you can get 2a cos kx sine omega t, or we can get 2a cos kx cos omega t. So these are all standing wave equations. Okay, these are all standing wave equations. And in this one, this here, this represents amplitude of standing wave, amplitude of standing wave. That is 2a sine kx. Now x represents what in that? X represents when you are going to keep different value of x, it is going to give you amplitude of different particles in standing wave. Because in standing wave, every particle is having different amplitude. How it is? As we said yesterday, we can say that suppose this end is fixed here. Okay, from here wave is generated. It goes like this. So we know that if it is a fixed end, from here there will be reflection. So if you are going to take reflection, it will come like this. Okay, so this is actually a standing wave. This is actually a standing wave. And in this one, these points are always at rest. We call them as node. And this is also node. And this here is also node. And the points where you have maximum amplitude, you can see that this point is called antinodes. This is antinodes here. And this is also antinodes. Okay, but if you look at all the particles that I said, that means particle is here also. Particle is here also. Okay, so what is the maximum amplitude they have? This is their maximum amplitude. This is how they are oscillating. Okay, particle here is oscillating like this. Particle here is oscillating like this. Okay, particle this one oscillating like this. So everyone is having different amplitude. Its amplitude is different, its amplitude different, its amplitude different. So every particle's amplitude will be given by this equation. Okay, what will be maximum amplitude? When the sine kx is maximum. Sine kx maximum means this, its value is 1. So that means maximum amplitude here will be 2a. And 2a is what? This plus this. Okay, so maximum amplitude of standing wave is 2a, whereas 2a sine kx gives amplitude of each and every particle. Okay, then what else we can say about the standing wave? We can say an information about this is, if suppose we are talking about these two loops. These two loops are there. So energy from this loop will not be going to this loop. That's why it's called standing wave. Okay. Energy of this loop is confined within the loop. Energy of this loop will be confined within this. It is not getting transferred. Whereas in transverse wave or a propagating wave, energy of this was transferring further. That's how energy was moving ahead. But here energy is not moving ahead. Okay, now this is fixed end. Is it moving ahead on that side? No, it's not moving ahead. Okay, so here energy is localized in the loops. Okay, energy is localized in loops. Okay, energy of one loop is not transferred to next loop. Okay, energy of one loop is not transferred to next loop. Then what? In this one, if the particles are vibrating or particles are moving up, in this one, if the particles are moving up like this, okay, then in this one, the same time particles are going down. Okay, so there is 180-degree phase difference between particles of two successive loops. Okay, there is phase difference of 180 degree between particles of adjacent loops. Okay, so that is important, you should know as far as standing wave is concerned. Okay, one, this is important. Second, this theory part is important. Okay, sorry. Let's move ahead then. So now we have a question, a simple question for you. This is a standing wave equation. You can see that kx is separate and omega t is separate in that one. So it's a standing wave. Okay, so what we have to find? It says amplitude. He didn't say amplitude of a particle which is situated at 5 centimeter or 10 centimeter. He just said this one. But wait a second, what we will do is, before that we will try to find out what are the positions of nodes and antinodes in this one. Okay, there is node, antinode, node, antinode. Let's see how to find the position. Okay, so we can do it here. Positions of nodes. Okay, so position of nodes. Now this is deciding the amplitude. Nodes means what amplitude? 0. This is 0 amplitude. So 2a sin kx equal to what? 0. Okay, it means sin kx is 0. Now the question is, at what value of sine we will get 0? Say sin 0 is 0, then sin pi is 0, then sin 2 pi is 0. So every multiple of pi, okay, sine value will be 0, including 0. Okay, so what you will write over here? This kx actually, kx equal to n pi. If kx is equal to n pi, then this is going to give me 0 1, where n can be what? N can be 0, 1, 2, anything. Okay, 0, 1, 2, likewise. Okay, so then x value is what? Say x value is, k we can write as 2 pi by lambda into x equal to n pi. Pi and pi gets cancelled. So x is n lambda by 2. Okay, we already have said that n is what? 0, 1, 2. So x value can be 0, lambda by 2, lambda, 3 lambda by 2 and so on. Okay, so first node is at 0, second one is lambda by 2, third is lambda, fourth is 3 lambda by 2. So what is the separation between consecutive nodes? This is 0, this is lambda by 2. So Separation between consecutive nodes is lambda by 2. Okay, then what about antinode? That also we should know. Correct. So antinode also we will do. Let's see. This one we will shift. Okay. All right. Are you able to see them? Is it visible to you fully? Or I'll take it here. Okay, fine. Okay. So now for positions of antinodes we'll do here. So this position, okay. All right. So positions of antinodes. Positions of antinode. Now antinode means what? Antinode means its amplitude is what? 2a plus 2a and minus 2a as well. Okay, here is plus 2a, but here minus 2a. Okay, when these particles are going up, these particles are going down. Plus minus 2a, shall we write? Okay. So what you will write then? 2a sine kx equal to plus minus 2a. This and this gets cancelled. So sine kx is plus minus 1. Plus minus 1 means pi by 2 1, 3 pi by 2 minus 1. Okay. So what we can write? Pi by 2, then 3 pi by 2. Okay. So that means kx value should be 2n plus 1 pi by 2 or 2n minus 1 pi by 2. Anything you can write. Okay. So when you are writing 2n minus 1, our n starts from 1. And if you are writing 2n plus 1, our n starts from 0. That's your wish. So kx equal to 2n plus 1 pi by 2. This is 2 pi by lambda into x. This is 2n plus 1 pi by 2. What we are getting? Pi and pi gets cancelled. So x value that I am getting here is 2n plus 1 into lambda by 4. Okay, 2n plus 1 lambda by 4. Now n value is 0. So x value comes lambda by 4. When you keep x value, n value, sorry, not x value. If you keep n value 0, it will come lambda by 4. If you keep n value 1, 2 plus 1, 3 lambda by 4. Okay, so it says that from here to here, this is lambda by 4. Okay, then antinode to antinode. This first value is lambda by 4, another value is 3 lambda by 4. So between antinode and antinode also, the gap is lambda by 2. So lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, like this, there will be position of antinodes. So this way we can find the position of nodes and antinodes in standing wave. Okay. Now let's see this problem. So this is standing wave, and standing wave we have to find amplitude. Now amplitude of which particle, which position, not mentioned. So here he is asking generalized amplitude. The generalized amplitude is this entirely is generalized amplitude. So 2 sine 2 pi x by 3. This is the amplitude. Okay. Then frequency. So frequency you will be getting from omega. Omega value is what? 300 pi. Okay. So omega is 300 pi. And omega is what? 2 pi into f. 2 pi into f is equal to 300 pi. So frequency equal to 150 hertz. Okay, frequency is 150 hertz. Then you have wavelength. Wavelength, what we will do? Wavelength is velocity by frequency. Okay. Wavelength is velocity by frequency. That's also, but at the same time we can write wavelength as 2 pi by k also. Okay, 2 pi by k. Because k is 2 pi by lambda. So lambda is 2 pi by k. K is there. Yes, this is k. 2 pi by 3 is k. Okay, let's put it here then. 2 pi by 2 pi by 3. So answer is 3. Okay. So wavelength is coming 3. Then what is left? Wave velocity. So velocity is frequency into wavelength. We know that. The frequency is 150 and wavelength is 3. So this is velocity. So it's easy. Basic terms, if you remember what are the basic terms, we can easily find all these terms in standing wave also. Okay. Right. One more question is there. A equal to 8 centimeter. That's amplitude. Amplitude of which wave? Amplitude of traveling wave. So amplitude is 8 centimeter, frequency is 35, velocity is 1.5 meter per second. What is the amplitude at x equal to 2 centimeter of a standing wave? Of a standing wave. Okay. So he wants what is the amplitude at x equal to 2 centimeter. Now we know that what we have to do. So if this amplitude is of propagating wave, okay, propagating wave, then amplitude of standing wave we will be writing as 2a sin kx. 2a sin kx. Okay, it's fine. Then, so this will be what? 2 into 8 into sin kx. Now, k value we have to find. It's not given. So, k value is what? 2 pi by lambda. K value is 2 pi by lambda. And lambda is what? Lambda is velocity by frequency. So, velocity given 1.5 and frequency is given 25. And this is lambda. So, that we will place. So, 2 into 8 into sine 2 pi by lambda. Lambda is what? 1.5 into here 25. So, it comes out to be 16 sine 50 pi by 1.5. That's all. That's the answer. Okay. So, we can find out amplitude at any point provided we have the basic information about a standing wave. Okay. Fine then. What else? Distance between two successive nodes is 15 centimeter. Velocity of wave 294. What is frequency? Okay, fine. We know that distance between two successive nodes is lambda by 2. So, lambda by 2 is given 15. So, lambda is 30. Okay, the frequency is V by lambda. So, V is given 294. Okay, 294 meter per second. This lambda is in centimeters. So, we will write it in meters, 0.3. So, it is 2940 by 3. Okay, so what will come? This is 9, this is 8 and 0. Okay, so that will be 980 hertz. Okay, so frequency will be 980 hertz. Simple questions. Okay. Right. Now, so far we were talking about waves, but in that one we never discussed about pressure wave. We discussed about displacement wave only. Okay. Now, what pressure wave is? Pressure wave is actually sound wave is a pressure wave. Longitudinal wave is called pressure wave. Okay. And so far we were talking about what? Transverse wave. Crust and trough we were talking. In pressure wave, you have compression, rarefaction, compression, rarefaction. Right. So, what is pressure wave? That we have to see first. So, pressure wave we said that it is because of the elasticity of the medium, and the measure of elasticity of medium is bulk modulus. Okay. So, what was bulk modulus? Bulk modulus was minus delta P by dV by V. So, it is actually dP by dV into V. dP by dV into V. Okay. So, when we are going to correlate this with displacement wave, okay, and we are going to correlate this with displacement wave. How to correlate? What he will do is, Here we are going to take dV by V, and here we are going to write minus dP by beta. Okay, so this dV by V, okay, dV by V comes out to be dy by dx of displacement wave. Dy by dx of displacement wave, that is equal to minus dP by beta. And what is displacement wave? Displacement wave we have seen as something like a sine omega t minus kx or kx minus omega t. You can write anything. Okay, so dy by dx will be what? Dy by dx is ak cos kx minus omega t. Okay, so then pressure will be what? Now dP is minus beta dy by dx. So this formula comes out to be minus beta ak cos kx minus omega t. Now this is pressure wave. This is pressure wave. Okay, this is displacement wave because particles are definitely getting displaced. Okay, but how pressure is changing? That is given by this wave, this form. Now, what is the phase difference between the two waves? This is sine function, this is cos function. So, displacement wave and pressure wave are 90-degree out of phase. Okay, phase difference between displacement wave and pressure wave is 90 degrees. Okay, now if suppose we are going to make it, okay, if we are going to make both displacement wave and pressure wave, how they are, see, if we make both here, this is for displacement wave and here we are going to make pressure wave. Okay, here is displacement wave, this is y and t, it's a sine function. Okay, it's like this, in this way. Pressure wave at the same time, is going to be the cos function. Okay, so we can make it like this. Okay, so cos function. In this one, here displacement is 0. Okay, here we take displacement 0. Here is 0, and this we call as A. Okay, but in pressure wave, what is the difference? Here this is atmospheric pressure. Okay, there is no 0, pressure can't be 0, so it's atmospheric pressure. Then what is this? This is amplitude, that is beta ak. This is the amplitude of pressure wave. Okay, here amplitude is A, here is beta ak. So what is the pressure here? Here is what pressure? Here is pressure P naught minus beta A, and here is P naught plus beta A. Remaining all the things are same. Okay, what is the frequency, what is the wavelength, everything is same. There is no change. But the function has changed. There is a phase difference of 90 degree between the two. Because of that, what is going to happen? Because of that, there will be difference in standing wave. Okay, what difference is there in standing wave? The previous one, standing wave that we were talking, that was displacement wave. Okay, where displacement wave, standing wave happens? In strings. In strings, we talk about standing waves as displacement waves. Okay, but in organ pipes you can define it in both ways, displacement wave as well as pressure waves. But we prefer pressure waves in organ pipe because it's easy for us. Okay, right. So this is pressure wave, this is displacement wave. And what is the phase difference between the two? 90 degrees. Okay, now if suppose we have to find certain places, they will ask you that, they will give you a wave and they will ask you where is pressure maximum. Okay, so how to find pressure maximum in this one? And this is the formula for you. dP equal to minus beta dy by dx. Wherever you see dy by dx is negative, that means dP will be positive. Pressure maximum means what? It should be on the upper side. Okay, wherever dy by dx is negative, that means dP will be positive, right? But wherever dy by dx is maximum and negative, their pressure is max. So in this one, where pressure is maximum, you can see. Where dy by dx is maximum, I can see that here only dy by dx is maximum. Because here dy by dx becomes 0. Slope is 0 here. Here only maximum. Right or not? So here maximum means dy by dx is maximum and it's negative also there. So pressure will be maximum at that point. Okay. That is how we have to see that. But this I saw it pressure wave. At pressure wave we don't have to see dy by dx. Okay. Here we have to see. This is displacement wave. So dy by dx will come on displacement wave. Not on pressure wave. So here is maximum slope and negative slope. And negative. So pressure here is maximum. You can see that. Corresponding pressure is this. So this is pressure amplitude. Okay. Remember that dy by dx is always on displacement wave, not on pressure wave. Okay. Right. So let's come to the organ pipe. Organ pipe is what? In organ pipe we are going to have standing waves. Okay. We are going to get standing waves in this also. Standing waves. So formula of standing wave same. There is no change in the formula. Okay. Same 2a sin kx cos omega t as far as displacement wave is concerned. Okay. So what to study in organ pipe? Two types of organ pipe we have: open and close. Open and close. Here is close. Open organ pipe means what? An open organ pipe means which is open at both ends. Okay, open at both ends. So we'll open this also here. Okay, closed organ pipe. Closed organ pipe means close at one end. Okay, close at one end. Okay, right. So now what we know in this open organ pipe, we know that there is atmospheric pressure here. This is atmospheric pressure. And here also atmospheric pressure. Okay, so when it's atmospheric pressure, then what is going to happen over there? Where is atmospheric pressure? Here. This is atmospheric pressure. This is atmospheric. This is atmospheric. This is atmospheric. Okay, so at atmospheric pressure, we are going to get node. When we are going to make pressure wave at atmospheric pressure, you are going to get what? Node. Okay, so it means here and here definitely node is there. Right. So if I make one standing wave, considering this to be node, and node means is what? What is the meaning of node? Node means is zero amplitude. It's like this. Like this will be standing wave. That means one loop. Okay. I am making one loop at the moment. We can have more? Yes, definitely we can have more. But this is one loop. Same in closed organ pipe, if you make, this is atmospheric pressure here. So this is going to be node. But this is not atmospheric pressure. So there will be empty node. So we'll be make like this. Okay. So here node and node. Here is node and empty node. Okay. So this we call as fundamental tone. Okay. We call this as fundamental tone. Now we all know that node and node. What is the difference between the two? It's lambda by 2. This is lambda by 2. And if we assume that the length of this organ pipe is L, okay, if the length of this organ pipe is L actually, Then we can equate L with lambda by 2. You can say L is equal to lambda by 2, right? L equal to lambda by 2. So lambda equal to what? 2L. Then what is the frequency of this organ pipe? Organ pipe means is musical instrument. Flute is example of this. We can understand flute in a better way. Okay. So lambda equal to 2L. So frequency is what? Frequency is actually V by lambda. So that means V by 2L. Okay. It is V by 2L. So this is called fundamental frequency. Why? Because you cannot have less than this loop. At least one loop is possible because here is also node, here is also node. So at least one loop will be there. And node is a point from where pressure wave is reflecting. Pressure wave gets reflected from atmospheric pressure. Remember that. Okay. Pressure wave is reflected from atmospheric pressure. Okay, remember that. So this is how you generated wave. It goes here, again atmospheric pressure, it gets reflected. Okay, so this is fundamental tone. Why fundamental? Because this is the minimum number of loop possible in this. Okay, so this is fundamental. So we are writing here, this is fundamental tone. Fundamental tone. What is that? V by 2L. And this is also called as first harmonic. Okay, this first harmonic. One loop, first harmonic. Okay, fundamental tone or first harmonic. Check there. Here is also minimum is there. One loop only, which is connecting node and anti-node, right? So length of organ pipe is L. Okay, its length is L. And what is the separation between node and anti-node? Say lambda by 4. Okay, that is lambda by 4. So this is lambda by 4. Okay, take this one. This is lambda by 4. Now we can equate L and lambda by 4. So what is the equation? L equal to lambda by 4, lambda equal to 4L. So frequency V by 4L. Again, this is fundamental tone and first harmonic. Fundamental tone and first harmonic. Okay. So this is one is open organ pipe, another one is closed organ pipe, and we got fundamental tone for them. Are these only possible? Answer is no. We can increase the frequencies. Okay. So if you are talking about open organ pipe, one more frequency at least we can make or see. Okay. So it's like this here. Now we know that here there is node where at the open end. Here is node. Here is node. So what I can do now, one loop I made in the previous one. Now I can make at least two loops. So assume that here is also one node. So make it like this. Okay. And here also like this. So we have made two loops now. Okay. Length of organ pipe is same, L. This is L only. Okay. This is L. But now in terms of wavelength, what it is? In terms of wavelength, it is how much? This is lambda by 2. This is also lambda by 2. Okay. So we can say that this is 2 lambda by 2. That means lambda. Okay. Lambda by 2 plus lambda by 2. So it's 2 lambda by 2. So what we can say now? L is equal to 2 lambda by 2, that is lambda equal to 2L by 2. Frequency is V by lambda. Then what we are getting? 2V by 2L. Now this 2V by 2L we'll call as first overtone. That means 1 over the fundamental tone. Fundamental tone you can call as 0th overtone. Now this is first overtone, and this is also called as second harmonic. Okay, so whichever, here 2 loops are there, so we call it as second harmonic. Next one, you make 3 loops, this will be third harmonic. 4 loops, it will be called fourth harmonic. And overtone is 1 less than that. So if I say the frequency in open organ pipe is NV by 4L, considering there are N loops. Okay, so we'll call this as what? Nth harmonic. And we'll call it as N minus 1 overtone. Remember that, okay? N minus 1th overtone. Okay, so what are the frequencies? I have written NV by 4L, NV by 2L. Okay, because this is open organ pipe. So this is NV by 2L. This is nth harmonic. Okay, this is nth harmonic, this is N minus 1th overtone. Now the same way we can see in closed organ pipe also. So closed organ pipe, if you make here, one end is closed and one is opened. So this is opened here. Okay. Now what we have? Here we know we have a node and here we have an antinode. Already we have seen fundamental. So we have to increase the number of loops. So suppose here we are making one node here. So this is how it is, like this, and then it goes in this way. And then here it's like this and like this. Okay. Then what we can say, this is L. Okay, this is L here, and this is how much? Now this is lambda by 2 and this is lambda by 4. Okay, lambda by 2 plus lambda by 4. So how much it is? 3 lambda by 4. Okay. This length will be 3 lambda by 4. 3 lambda by 4. So we can say L is equal to 3 lambda by 4. So lambda equal to 4L by 3. So frequency, which is V by lambda, it will come as 3V by 4L. Fundamental was V by 4L. This is 3V by 4L. The 2V by 4L is not there. So in open organ pipe, remember that even harmonics are not present. Even harmonics are not present. Okay, only you will be getting odd harmonics. So what we will call this as? We will call this as third harmonic. Or first overtone. Overtone, there is no problem. Okay, it is one above the fundamental. Next is this. So we'll call this as first overtone, but harmonic is third. Next one, 5V by 4L, fifth harmonic and second overtone. Okay, so if I say in this there is nth overtone, then which harmonic it is? 2n plus 1 harmonic. You can check that one. Okay, if here overtone is 1, let's put 1 over here. 2 into 1 plus 1, third harmonic. Okay, same way if you have second harmonic means 5, second overtone means fifth harmonic. So second overtone n equal to 2, you keep here 2 into 2 plus 1, see fifth harmonic. Okay, so nth overtone means 2n plus 1th harmonic, and here nth harmonic means n minus 1th overtone. Remember that in both closed organ pipe and open organ pipe, this is the difference. There are many questions you will find on closed and open organ pipe. Okay, right, what it is, let's see the question then. Okay, so what question says, in an open organ pipe, frequency obtained are 25 Hz, 30 Hz, 35 Hz, 40 Hz, like that. Find fundamental frequency of organ pipe. So certain frequencies are given. Which frequency it is, which harmonic it is, nothing is given to us. And he is asking us find the fundamental frequency. So what to do? In this case, if suppose that successive frequencies are given, we are going to find out the difference between successive. And you can see that there is same difference between any two successive, you can see 25, 30, 35, 40. Okay, so difference between successive frequencies. Difference between successive frequencies. What it is? 5 Hz. Okay, it is 5 Hz. That only is fundamental frequency. Fundamental frequency is 5 Hz. So this 25th means which harmonic? Fifth harmonic. This is fifth harmonic. Fifth harmonic, right? Or which overtone? Fourth overtone. Okay. Now if the same question is given for closed organ pipe, same question is there for closed organ pipe. Okay. Exactly same. So if we take this one, can be selected? No. Okay. Fine. So I am writing it for same question in closed organ pipe. What you will do? Same question means same frequency given 25, 30, 35, 40 Hz. Then what we should do in closed organ pipe? Okay. Find fundamental frequency. Now in this one also process is same only. We are going to find what is the difference between two successive frequencies. Okay. Difference between two successive frequencies. Okay, what is that? Is it 5 Hz? Okay, the frequencies are 5 Hz. Okay, we will do one thing. We will not do the same question because in this one 25, 30, 35 are given. That will not be possible for closed organ pipe. Okay, we will change the question. Same question I have written. No? Just change the question, then we will do it. Okay, what should be the question? Should be in a closed organ pipe, frequencies obtained are why I am saying it's not possible? Because in closed organ pipe only odd harmonics are present. All harmonics are not present. Whereas in open organ pipe, all harmonics are present. So that's why in closed organ pipe you will not get the same value. Okay. So in a closed organ pipe, frequencies obtained are 25 Hz, let's say first one. Then next one is 35 Hz. Then it will be 45 Hz. Then be 55 Hz. Like that it will. Okay. So find fundamental frequency of organ pipe. Find fundamental frequency of organ pipe. Now what we are going to do? As I told you, we are going to find here also the difference between two successive frequencies. Okay. So difference between successive frequencies, what it is? You can see 10 hertz, 35 minus 25, 45 minus 35, 55 minus 30. So 10 hertz. Now, can I say 10 hertz is the fundamental frequency? I can't. Reason is because 10 into 2.5 is 25 hertz. Okay, it is not the harmonics that we get in that. Right? 35 is also 3.5. 45 also 4.5. So this is not correct. Same logic we cannot apply in this. Then what it is? This difference between successive frequencies is actually 2 times frequency fundamental. Okay. This is 2 times the fundamental frequency. So what is fundamental frequency then? 5 hertz. Remember that. Okay. Fundamental frequency is 5 hertz in this also and in this also. Okay. So which harmonic is this? Which harmonic? 5th harmonic. This is 7th harmonic. This is 9th harmonic. This is 11th harmonic. Okay. Which overtone? If this is 5th harmonic, then which overtone is this? 2nd overtone. 5th harmonic, 2nd overtone. Okay. So note this one, rather anyhow you will be getting it. Fine. Okay. Let's move ahead. Right. Then what else can be asked in this organ pipes from us? In this organ pipe, there is one more thing, one experiment is there. Okay. To find out the speed of sound. Okay. The speed of sound. Through resonance column method. Through resonance column. There is one formula that we have to remember in this. Okay. Speed of sound through resonance column. So which organ pipe we are going to take? Closed organ pipe. Closed organ pipe we are taking this. Okay. So closed organ pipe is taken and this is filled with water. This is filled with water. And one tuning fork is taken. And this tuning fork's frequency you already know. Okay. Known tuning fork. Okay. What are we going to do? Now this is organ pipe. Now this organ pipe also produced frequency. Yes, we saw that. NV by 4L is its formula of frequency. Various frequencies it can produce. We can keep N value 1, 3, 5, 7, like that. Many frequencies will be there. So what is the process here? We are bringing this tuning fork close to this one. Okay. So when you are bringing it close to this one, this also starts vibrating. So when frequency produced by this and frequency produced by the tuning fork becomes same, then resonance happens. That means you get more sound, more buzzing sound you will be getting because tuning fork produces buzzing sound. Okay. When they are not in frequency, you will not be getting loud sound. Once that same frequency of this and this is approaching, you will be getting loud sound. Okay. So now question is, if this our organ pipe is full, okay, are we going to get anything? Answer is no. Why? Why not? Because I want air column for frequency to develop. So here at the moment there is no air column. So what I have to do? I have to decrease the level of water. Okay. And this level of water here, this top layer of water, that is going to produce node or antinode in pressure wave. We are talking in terms of pressure wave. Okay. So as I told you, node for pressure wave is always at atmospheric pressure in air. Okay. This will be taken as closed end only. The water surface means is denser than air. Right. So it will be taken as closed surface. So reduce the level of water in this one. Okay, this length we will write, this is L. Okay, so we are decreasing the level of water in this. Is it possible to do or not? No. All right. So we'll make one more time. Here it is. Okay. Now in this one, what we did, we decreased the level of water. So for decreasing the level of water, what is there? There is a hole in this. So we decrease it. Okay. So this is what available to us now. Okay. So in this one, one standing wave can produce. Okay. The standing wave can be produced like this. Okay. Fine. So now this standing wave, suppose that this standing wave's frequency and this matches, then we will say resonance is there. Right? So this we will measure what is this length at which resonance is observed. Then one more frequency will obtain. One more time. So again we will make it. One more time we will make. Why one more? Because then only we are going to get the speed of sound. At least two values required. So this time suppose the level is here. Okay. Level came to this point. Now what's happening? It's like this. Okay, now this is L2. We measured. Okay, you can see that this is actually 3 lambda by 4, whereas this is lambda by 4. Okay, L1 is lambda by 4 and this L2 is 3 lambda by 4. So we measured this L1 and L2. Okay, then we have a formula. If you remember that formula, you have to remember that formula. Okay, so V equal to 2F into L2 minus L1. Okay, speed of sound is equal to 2 times frequency. Which frequency? Frequency of tuning fork. Okay, so V equal to 2F into L2 minus L1. Clear? This we have to remember. Okay, V equal to 2F into L2 minus L1. This is resonance column method through which we find speed of sound. In speed of sound, what we are doing? We are finding two lengths in this one. Okay, length of air column, so that we can get the resonance. This one we will measure, this will be measured, and we put it into this formula, we will get the answer. How questions will be asked from you? They will give you two lengths. Okay, in an organ pipe to measure the speed of sound, two length of air columns are measured. Two lengths they will give, 5 centimeter, 15 centimeter. Find the frequency of, or rather, find the speed of sound. Something I'll try to make. Okay, let's see if we are able to make one question on this one. See now. Not necessarily they will write to measure the speed of sound, because when we write to measure the speed of sound, immediately it clicks in your mind that they are talking about resonance column. So it's not necessary, but you have to be aware. Okay, whenever they say there are two lengths of organ pipe, immediately it should come in your mind that this is a question related to resonance column. Okay, to measure the speed of sound, two lengths of air column are measured are 5 centimeter and 12 centimeter at frequency of 100 hertz. Okay, find speed of sound. Find speed of sound. Like this question is given. What we have to do, if you remember that this is actually resonance column, then we can solve it very easily. You can say V equal to 2F into L2 minus L1. Okay, so 2F means 2 into 100. L2 minus L1 means 12 minus 5 into 1 by 100, because these are in centimeters. Okay, so 100 and 100 gets cancelled. This is 7 into 2, 14. So 14 meter per second. Like this, we will be getting the answer when we are talking about resonance column. Okay, fine. Then now what? Then now we are going to study beats. Beats is what? Beats is also superposition of two waves. Okay, but in this one, frequency of two waves is not same. In standing waves, frequency was same, because another one we can say is coming after reflection. Okay, and in reflection, frequency of wave was not changing. But in beats, you have two waves which have different frequencies. How much difference frequencies? When frequency difference between two waves is less or equal to 10 hertz, less or equal to 10 hertz, then only beats are observed. That's very important point. If the frequency difference comes out to be 15, then they will ask you what is the beat frequency? Answer is 0. If it is less than or maximum equal to 10, then only we will be finding beat frequency, otherwise it's 0 only. Okay. So when frequency difference between two waves is less or equal to 10 hertz, then only beats are observed. What is beats? Number of maximum intensity sound or minimum intensity sound, observed in 1 second. In 1 second. That means intensity is not constant. Intensity is going to increase also, intensity is going to decrease also. So how many times maximum intensity is happening in 1 second, or how many times minimum intensity is happening in 1 second, that we call as beat frequency. Okay. Number of maximum intensity sound or minimum intensity sound observed in 1 second is called beat frequency. And this happens only when there is a difference in frequencies of two sources. Okay, or there is difference between the frequencies of two waves which are going to interfere. Okay, so what then? What we know about beat frequency? Okay, so what we know about beat frequency actually? Beat frequency is actually the difference between the frequencies of two waves, two interfering waves. That's all. Nothing much we should know about that. Beat frequency is F1 minus F2. Okay, now what type of questions we expect in this one? So questions expected in this one are like this. Okay, questions expected are what? Suppose y1 given to you, y1 is 10 sine 4x plus 100t, and y2 is also 10 sine 4x plus 102t. Okay, so two waves equations are given. They are asking find beat frequency. Okay, so beat frequency means what? We have to find the difference between the frequencies of two waves. Right? So solution. What is frequency of this one? So F1 we have to find, and we know that omega is given to us as 100. Omega is given to us as 100. So what is frequency? Frequency is 100 by 2 pi. Okay, this is F1. Same way here, this is 2 pi F2 is equal to 102. So what is F2? 102 by 2 pi. Okay, so and what is the beat frequency? Beat frequency is F1 minus F2 or F2 minus F1, because beat frequency can never be negative. You say 100 minus 102, so it will be coming negative. Negative is not possible. So what we will do? What we will do here, not this one here. So I will be putting this into mod. Okay, F1 minus F2, this cannot be negative. Okay, alright, so come here. So what we will do here? Here we will do F2 minus F1. 102 by 2 pi minus 100 by 2 pi, that is 2 by 2 pi, that is 1 by pi hertz. This is the beat frequency. Okay, now same question I make in different way. Same question. Question now is y1 equal to 5 sine 4x plus 100 pi t and y2 equal to 5 sine, okay, 5 sine 4x plus 150 pi, right? And question is saying find beat frequency. Find beat frequency. So its answer is what? First of all, let's find what is frequency here. So omega 1 is 100 pi, that is 2 pi f1 equal to 100 pi. Pi gets cancelled, f1 is 50. Here omega 2 is 150 pi, so 2 pi f2 equal to 150 pi. Pi gets cancelled, f2 is 75. Now f2 minus f1, f2 is greater, so f2 minus f1 is more than 10. f2 minus f1 is actually 25. So f2 minus f1 is more than 10. So no beats. No beats are heard. Okay. Then what other questions are there? Now beats question are there to compare. Okay, we are saying two waves are there. Now they will be comparing different instruments. Like two organ pipes they will compare. Tuning fork and organ pipe they will compare. Organ pipe and guitar they will compare. Guitar means is string fixed at both ends. Okay, guitar they will compare. So like this they will be comparing and asking you about beat. Okay, let's have a question of all. If possible, we will take questions of all. Okay, but before that there are two processes we discuss more in beats. That is for tuning fork. One is vexing of tuning fork, another one is fiving of tuning fork. Okay, so vexing of tuning fork. Vexing of tuning fork. So when you do vexing of tuning fork, that means you are applying vex on it. Okay, so vexing of tuning fork means what? Increasing mass or inertial property. Inertial property of tuning fork. Inertial property of tuning fork. So if you increase inertial property, then what will happen to frequency? Frequency will decrease. Okay, if you are vexing the tuning fork, its frequency decreases. Increasing inertial property of tuning fork, then frequency of tuning fork decreases. Okay, on this also question is asked once. What is the question? Question was like this. A tuning fork has frequency of 420 Hz. It is vexed. What can be its frequency? What can be its frequency then? And then options: greater than 420, less than 420, equal to 420, and D option, not inclusive or information not enough, not conclusive. Now we know clearly that if you are applying the wax, its frequency is going to decrease. So obviously what it will be? Less than 420. What else? Okay, it will be less than 420. So when you are waxing a tuning fork, its frequency decreases. Okay, there is another process. Another process is filing of tuning fork. Filing of tuning fork. Okay, so filing is here. Now, filing means is what? Filing means is making smooth. Okay, making it smooth. Something what happens is when you are doing the experiment in lab, certain particles will stick with the tuning fork. Okay, some unwanted particles, dust particles, sand particles, or maybe chips of iron, something will stick. So what you do is you clean it. Filing means is cleaning of tuning fork, removing unwanted particles from that. Okay, a process of cleaning or smoothing of tuning fork. Smoothing of tuning fork. In that one, what will happen? In that one, inertial property is going to decrease. Okay. In the process, mass will decrease. No, unwanted particles will go away. So, inertial properties decreases. In the process, inertial properties decreases. So, what will happen? Frequency will increase. Frequency of tuning fork increases. Frequency of tuning fork increases. Right. So, filing means increasing the frequency and waxing means decreasing the frequency. So, based on this, you will find many questions. Okay, how? Just see. The question says, tuning fork A produce 5 beats, with tuning fork B having frequency 350 Hertz. Okay, then when tuning fork A is filed, beat frequency increases. Find frequency of A. Find frequency of A. Okay, now this is question. So, in this one what we say, tuning fork A produce 5 beats with tuning fork B having frequency 350 Hz. Now, we know that beat frequency actually is difference of frequencies. So this 5 beats can either be FA minus FB or this can be FB minus FA. We don't know which one is correct. We have to see that further. Okay, from first information we are writing it. The second information that he says is, he says A is filed. That means this A is, you are filing means you are increasing the frequency of A. You are increasing the frequency of A, correct? He says beat frequency also increases. If you increase the frequency of A, beat frequency also increases. What is beat frequency? This, what is given over here. Either this or this. Okay, so you increases the frequency of A. So that means FA you are increasing. When you are filing A, you are increasing frequency of A. At the moment we are writing FB minus FA is 5. Frequency of B minus frequency of A is 5. If I increase this, then this is likely to increase or decrease? Decrease, because you are increasing this. So this is going to decrease, but question is asking it should increase. So that means this step is wrong. Check here then. So here is FA minus FB is 5. Correct. If I am filing A, that means its frequency you are increasing. Whose frequency? FA. So if FA you increase, will this be more than 5? Answer is yes. If you increase this, already it is FA minus FB 5. If you increase FA, obviously this is going to increase. So that means this equation is correct. But what is the answer? Let's put FB. 5 equal to FA minus 350. So that means FA value is 355 Hz. FA value is 355 Hz. Again, A is filed. That means A's frequency you are increasing. So beat frequency also is increasing. Where it is possible? In this one, it's not possible because you are subtracting A from B. So if B is same and A increases, then difference is going to decrease only. It will not increase, but question wants to increase it. So only this is possible. Okay, same way another question if you do. This time for vexing. So see, two tuning forks are there. I am not writing the statement, okay. Suppose FA again is unknown. FB is 420. Okay, so beat produced is equal to 8. Okay, beat frequency is 8 Hz. Now, if A should we do or B? Okay, this time we'll go for B. If B is vexed, beat frequency decreases. Find frequency of tuning fork A. Find frequency of tuning fork A. Okay, this is given to us. What we do? First, let's write what we know. Okay, what we know is beat frequency. So either it will be FB minus FA or FA minus FB. Okay, it will be either FB minus FA or FA minus FB. So let's do that. FA minus FB is 8 or FB minus FA is 8. Now we'll look at what the question is asking. It says B is vexed. B is vexed means you are decreasing the frequency of B. Okay, then what? Beat frequency also should decrease. Okay, so if I am going to decrease B's frequency, then FA minus FB is going to increase or decrease? If I decrease the value of this FB, FA minus FB will increase only. Correct or not? It will not decrease. But question wants, then which one? Let's see this. FB minus FA is 8. If I decrease FB, what will happen here? Decreases. That means this is correct and this is wrong. This is correct. Now what is there? Nothing. Okay, what is given? FB. So 420 420 minus FA equal to 8. So FA equal to 412. That's all, over. Okay, now let's make it in different way. We are not comparing two tuning forks. Let's say we compare it with any organ pipe. Okay, and two organ pipes also we can compare. Two organ pipes also we can compare. Okay, how? Okay, first I'll ask you standing wave question, then we'll talk about beats. An open organ pipe of length 20 centimeter, an open organ pipe of length 20 centimeter is played with closed organ pipe of length 40 centimeters. If open organ pipe is played in first overtone, then find harmonic in which closed organ pipe is placed, for resonance. Resonance means same frequency. Okay, so open organ pipe is played in first overtone, then what is the harmonic in which closed organ pipe is played? Okay, what to do? Simple question. We want frequencies of both to be equal. Okay, so first overtone. First overtone means which harmonic for open organ pipe? Second harmonic. That means 2V by 2L. Okay, so 2V by 2L of open organ pipe. Which harmonic of this one? Let's see. We don't know. I am writing nth harmonic. Okay, V by 4 times length of closed organ pipe. So V is cancelled, velocity of sound, so that is gone. This 2 and 2 also we can cancel here. So length of open organ pipe is what's given? 20. So 1 by 20 here equal to N by 4 LC. 4 into what? 40. Okay, so N is what? N is equal to 160 by 20. N is coming 8. 8th harmonic, which is not possible in that, but okay, fine. Because even harmonics are not possible in that. It has to be odd harmonics all the time. What we can do? I can make a little change in that. Okay, let change in the question. What change is possible? This length I can make it as 35 centimeters. Now it's fine. Okay. So what we can do here? This is 35. 35 means that will come as 140. Okay, so this is 140. Answer is 7. So seventh harmonic. Seventh harmonic which overtone? Which overtone? Third harmonic means first overtone, fifth harmonic means second overtone, seventh harmonic means third overtone. So seventh harmonic, okay, and third overtone. In this one also I could have made that two organ pipes are produced together and they produce certain beats. Okay, they produce certain beats, and suddenly in one of the organ pipe I have decreased the level of water. And then beat frequency increases or decreases. Like this also we can do. Okay, like this also we can change the question. So you should be able to find out what is happening. Okay, and in guitar also, what is guitar's frequency actually? That means string frequency. Guitar means which is an instrument played with string. So string frequency also is just like open organ pipe. Okay, string fixed at both ends. Okay, so its frequency is also NV by 2L. Same like open organ pipe, but the difference here is when we talk about this frequency, this is N by 2L, this is length of string, V here is root over T by mu, velocity of wave in string, whereas in open organ pipe or organ pipe, okay, when we are writing frequency as NV by 2L, NV by 2L, in this one, this velocity is what? Root over beta by rho. Okay, root over beta by rho or gamma RT by M, root gamma RT by M, because this is for sound. This is for sound in air. So standing wave that is being produced, that is in longitudinal wave, whereas here standing wave is in transverse wave in a string. So N by 12 root over T by mu. Remember that? This is for string and this is for organ pipe. So can we mix up them also? Yes, we can mix up them also. How? Just see. Question is an organ pipe, not organ pipe, just write a flute. Okay, a flute produces 5 beats when played along guitar. Okay, if tension in wire of guitar is increased, beat frequency increases. Find frequency of guitar or flute. Find frequency of guitar. Then frequency of flute is what? Let's say frequency of flute, let's say as 200 Hertz. Okay, frequency of flute is given to us as 200 Hertz. Right? How to do this? Same method, there is no change in the method as such. Okay, that is FA minus FB again. So F of flute minus F of guitar. Okay, F of flute minus F of guitar. How much is given? 5. Let's see. So in solution, so F of flute minus F of guitar is 5, or F of guitar minus F of flute is 5. Okay, what question says now? If tension in wire of guitar is increased, tension is increased. Now tension means what is happening here? I said this is the frequency of guitar. If tension you are increasing, then frequency of guitar you are increasing. two things are changed. Okay, one is tension, other one is length. If length is increased, then frequency you are decreasing. If tension is increased, you are increasing the frequency. Okay. So in this one we change tension. So if tension in wire of guitar is increased, means you are increasing the frequency of guitar. Then what question says? Beat frequency also increases. So which is possible equation out of the two? Second one. Because if you increase the frequency of guitar here, FF minus FG, then this should be decreasing. Where beat frequency is increases? Here. If you increase frequency of guitar, possible here is increase in this. So this is correct, this is wrong. What is frequency of flute given? 200. So frequency of guitar will be 205. Certain times they will compare two guitars. Two guitars are there. In one tension is 200 hertz, another one is 210 hertz. Both are of the same length. Okay, and fundamental frequency, if it is being played, then what is the ratio of the frequencies? Okay, fundamental frequency means n is 1, right? So what they want ratio of the frequencies. The ratio of the frequencies is what? If the length is given same, if length also can be different also. Okay, so if the length is given the same, then we will say like this, it's root T1 T2. Okay, or if length is given different, then F1 by F2 will be equal to L2 by L1 into root over T1 by T2. Okay, so it depends on how the question is asked from us. So beat is the most important topic. Okay, you can find many questions on beats. Beats can be asked between two organ pipes, as I said, can be asked between two tuning forks. They can be asked between two guitars or two sonometer wire. Sonometer wire is same as guitar. Or sonometer wire and organ pipe, sonometer wire and tuning fork. Anything can be asked. Now since Doppler's effect is not there, otherwise Doppler's effect also could have been brought into beats. So beat is very important topic, right? So that's all as far as sound is concerned, waves and sound. This is it. Okay, now go study and solve the problems on this one. Tomorrow we are studying 12th portion and very important, electromagnetism. We start with electromagnetism first. Okay, and most important topics of 11th are what? What do you felt like? What are the most important topics? Heat and thermodynamics, very important. Okay, mechanics is big. In mechanics we have to talk about individual topics, and gravitation is important. Okay, rotation is important, work power energy is important. Then you can have kinematics and laws of motion. Together, if you take both of them, including units, dimensions, together they become like significant. Otherwise, individual chapters will have one question maximum or two questions maximum. But work power energy is big, rotation is big, gravitation is big, and then heat and thermodynamics is big. Then you can call SHM and waves also maybe 2 to 3 questions at the most. Okay, and waves, along with that, wave optics also will come. So there are certain things which in wave optics is also very similar to waves. So you can include wave optics also. So considerable portion is there for 4 or 5 questions actually. Okay, but if you think about something like gravitation, a single chapter can give you 2 to 3 questions. So important topic. Okay, so fine then. See you tomorrow, students, with electromagnetism. Bye bye, and take scan the QR code so that you can revise it very fast. All the topics that we have discussed, you can revise it very fast. Okay. Scan it. Completed, students? Yes, sir. Okay then. Alright, then see you tomorrow. Bye bye.
you, sir.